Today we are going to break down a real-world system design use case, sending order confirmation emails asynchronously using AWS services. This is a classic example where asynchronous processing dramatically improves both user experience and system reliability. We'll explore why asynchronous is the right approach and how we use AWS services like Lambda, XQS, and SES to make it happen. Let's dive in. Why asynchronous? So first, why do we need asynchronous processing? Let's say a user places an order. If we wait to send the confirmation email synchronously in the same flow, what happens? The user must wait until the email is sent. If the email service is slow or unavailable, the order process fails. The checkout becomes slow and unreliable. That's bad UX and bad engineering. Instead, we use asynchronous processing. This means we accept the request immediately, offload the slow work to the background, and let the user move on without waiting. Now, let's look at how this works in AWS. The flow starts with the user placing an order through your front end, maybe a website or mobile app. This request goes through Amazon API Gateway, which securely exposes your backend services as RESTful APIs. API Gateway then triggers a Lambda function. This is where the order is processed. Here's the important part. Once the order is processed, we don't send the email right here. Instead, we push that email task to a message queue. This is our async handoff. The Lambda pushes a message to Amazon SQS, a managed queuing service. This message contains everything we need to send the email. User's email, order ID, email template name, maybe even language preferences. This is where asynchronous processing begins. The Lambda exits immediately after pushing the message. This ensures the checkout flow is fast and doesn't depend on email delivery. Now, in the background, a separate Lambda function or an EC2 worker listens to this queue. It picks up the message and uses Amazon SES, the simple email service, to send the actual email. Since this is happening outside the main user request, any delays or failures in email delivery do not affect the user. And because this is fully decoupled, we can scale this email worker independently. Need to send 10,000 emails? Just add more workers. To make the system observable and reliable, we connect both Lambda functions to Amazon CloudWatch. We log API errors, queue processing status, email send success failure. And if sending the email fails, maybe due to a bad email address or SES rate limit, we use a dead letter queue, DLQ. Failed messages get routed there, where we can retry later or analyze what went wrong. This makes the system fault tolerant without risking failure cascades. Let's recap the benefits of this asynchronous approach. Faster user experience. Users aren't stuck waiting for emails to send. Resilient architecture. Email failures don't break your order system. Scalable processing. Scale the workers without touching the checkout. Decouple components, easy to maintain and evolve independently. And the best part, all of this is fully serverless on AWS. Highly available, low maintenance, and cost effective. And that's it. That's how you design an asynchronous order confirmation email system using AWS services like SQS, Lambda, and SES. This is one of the most common patterns used in production systems to keep this thing snappy, safe, and scalable. Please feel free to subscribe and drop a comment.